All right, let's start talking through the bell work. So they tell me right at the beginning that A is 1. That means there's no stretch, there's no compression at all on this parabola. First thing they asked me to find was the roots. What are we looking for on the graph if it says to find the roots? Yes, we want to find our x-intercepts, the 2 points where it crosses the x-axis. So looking at our graph, where are those 2 points? -2, and where else? +4. We want to write them as ordered pairs. So what would these ordered pairs look like? Yes, -2, 0. Oh, not right there. And +4, 0. We'll come to the factored form at the end. I want to get through all these other features, and then we'll talk about our forms. Where is the axis of symmetry? Be careful and give me the whole thing. X equals 1. If you don't have the x equals part, it is incorrect. Axis of symmetry cuts this parabola right in half, and I see that I would go through the x-axis at 1 if I were to do that. That's how we get this. Where is the vertex itself located? 1, -9. Right down here is my vertex. So at 1, -9. And then we're going to do the transformations. Then we'll go back and talk about those forms. So for the transformations, I don't have AHK form that I can look at. They told me my A value, so I know I don't need to describe a stretch or a compression or a reflection at all. But I still need to figure out how this has moved or shifted from the parent. You can always use the vertex of a transformation to talk about any left or right shifting and any up or down shifting. The parent function has its vertex right at the origin. So if I go and I put my finger on the origin, I need to describe in words where my finger would go, how far in which direction to get to the vertex of this guy. Yes. If you start at the origin, you go to the right 1, and you go down 9. That's what I'm looking for on the description of the transformation there. All right, forms. To write the factored form, we need our roots. Factored form is the one that starts with A, but then it has 2 sets of parentheses, x minus R1 and x minus R2. We have all the pieces that we need to be able to write this. I start with a y equals. Then I need my A value. What's our A value? 1. If your A is 1, do you have to write it there? No. So if you choose not to write the 1, that's okay, but it's perfectly fine to write it in as well. Then I need my factors. I have my roots, which isn't the same thing, but it's very, very close. Looking at those roots, the x part of the first ordered pair is -2. The x part of the second ordered pair is a +4. Factors are always equal to 0. X equals -2 is not equal to 0, but what would I need to do to it to make it equal to 0? We're going to add 2 to both sides. That would give me a 0 over there on the right. What would it give me on the left?
2x.
Close. 2 plus x, or x plus 2. If we write 2x, that means we're multiplying and we're actually changing the operation there. So I have x plus 2. It is now equal to 0, so I know that this right here is a factor. That's what's going to go inside my first set of parentheses, x plus 2. I need to make this a little bit lower. There we go. Close. I have my equals right here. I need to make it equal to 0. Yes, x minus 4. We'll subtract 4 from both sides. So then I have x minus 4 equals 0. And as soon as I get it equal to 0, this is my factor. So I have x minus 4. That is my factored form. As you guys practice this more, if you get to the point to where you can look at those roots and you don't have to set up these equations right here, you know you're going to switch the signs, and so you can just write your factors from that, I'm okay with that. We'll see by the end of today that we're getting a little bit faster at that. And if you don't have to show all your work for this, you don't need to show that for me. I won't take off points if you don't show me this. Vertex form. Vertex form is our AHK form. We have all the pieces that we need to write that one as well. It's going to start with a y equals. We know our a value, right? 1. And then I'm going to need parentheses that are squared. The parentheses have an x inside. And then right here, I don't see h, but what do I see? Not r. Remember, this is my AHK form. Why is this not h right here? What is it instead? I'm not looking for a number right now. Opposite of h, yes. This is the opposite of h that goes in here. What is our h value? 1 from my vertex. I see h right here. What goes in the form, though, is the opposite of h, and I think this is what you were saying earlier, Lauren, and possibly you too as well, Soraya, I'm not sure. Yes, I'm going to see x minus 1 inside those parentheses. What's going to go on the end? Negative 9. Because that is my k value. I want to practice a little bit more with forms from a graph. If you flip forward in your books to page 63, there's 2 graphs there, and we're going to practice writing the factored form and the vertex form, and then we're also going to practice how to get to general form or standard form from there. So again, page 63 in your books, 6-3. All right. We are going to assume that A is either equal to 1 or A is equal to negative 1. How would I know from looking at the graph whether the A is a positive 1 or a negative 1? Yep. If it's pointing up, like this one, my A value would be 1. What's the A value on this graph over here? Negative 1. How do you know? Yes. This opens down. We need our A value to write all 3 forms because all 3 forms have the same A in them. To write my factored form, I need to look at which feature on the graph. Not the vertex. Not for my factored form. I need my roots. Which form will use my vertex?
Your vertex form?
Yep. Vertex form uses the vertex. So let's go find our roots first. I know the numbers are kind of fuzzy on here, but I think we can make it out well enough. Yep, you don't have any lines on yours? Yeah, they did not print well. In fact, they didn't even show up well on here. So the digital version doesn't have very good lines. This one is at -3. So we have -3, 0. And this one is at a +1. My factored form, y equals a times x minus r1 times x minus r2. I'm going to start writing this out on the line. I have y equals, what's our a value? 1. And then I know we're going to have 2 sets of parentheses, and each set of parentheses is going to have a factor in it. Yes. We're going to have x plus 3 and x minus 1. Who can explain to me why we have?
You do the opposite.
Yeah, opposite.
Opposite, yes. So for this first one, I would take x equals -3 coming from right here, and we would add 3 to both sides so that it's equal to 0. And that's what I use to get my factor. We do the exact same thing for the other one. X equals 1. I subtract 1 from both sides to get it equal to 0. So here's my other factor. Absolutely correct. Let's go do the vertex form next, and we'll come back to that general form, standard form. Vertex form is my AHK form. I need to identify my vertex first. Is it a maximum or a minimum on this graph?
Maximum.
No, minimum.
Minimum, because it is a lowest point. When it opens up, our vertex will always be the lowest. So right down here, I'll go ahead and give you guys the ordered pair for that. That's -1, -4. That's important because it's telling me the H and the K that I'm going to use. So I have all the pieces that I need for vertex form. I have my A from the beginning. They told me, or we made this assumption at the beginning, that our A was 1 because it opens up. And then I have these squared parentheses, and I know we have an X inside. Inside the parentheses, I don't see H, but I do see the opposite of H. Yep, so we have a +1 here. And then what's going to go on the end? -4, because that's our K. Now let's talk about our standard or our general form. This is the ABC form. Y equals AX squared plus BX plus C. I have to use either my factored form or my vertex form to find this one. I can't just look at the graph for this one. I want to practice using our factored form. So I need to find a little bit of open space. In between these 2 sets of parentheses, does anybody know what operation is happening there? Multiplication. So I am going to multiply these 2 factors together in order to get my general form. We have to use double distribution. I have 2 terms in my first set of parentheses, so I'm going to have to distribute both of those. I'm going to take the X, and I'm going to distribute it to both pieces here. So that would give me X squared minus x. And then I have to take the 3 and I have to distribute that as well. So I have plus 3x minus 3. Are there any like terms that we can combine together? 3x and the negative x, yes. That's a negative 1x and a positive 3x. What do I get when I combine those together? 2x. So I have x squared plus 2x minus 3. And the last thing I would need to do here is to distribute this a value to everybody on the inside. But what happens if I distribute that 1 to everybody? Stays exactly the same. So my general form is y equals x squared plus 2x minus 3. We're going to practice that idea a whole lot more today. Let's go look at the other graph. To do my factored form, I need my roots. What do you notice about the roots on this graph?
They don't, it's no x-axis.
Are there any points on the x-axis? The vertex is on the x-axis, so this is both a root and the vertex. Since there's only one root, and that one root is the vertex, that means my vertex form and my factored form will be identical. Absolutely 100% the same. Negative 1 and 0 are the root / vertex. So I'm going to go ahead and write this factored form then. I have y equals, what's my a value? Negative 1 because it's upside down. You do have to have the negative sign. If you choose not to write the 1 part, that's okay, but you have to have the negative sign. How would I write this root? Or sorry, this factor, not the root. X plus 1, yes. So it'd be x plus 1. This is called a double root.
So it'd be the same.
It'd be the same thing again for the other one. When I take something and multiply it by itself, what's an easier way of writing that? Squared. And that's why my vertex form and my factored form are identical here. I have x plus 1 times another x plus 1, so x plus 1 squared. I need my standard form, my general form. I'm going to use the factored form to demonstrate this. We'll practice with the vertex form here in just a minute. I have the negative 1 here. I have x plus 1. And I have another x plus 1. I'm going to focus just on these pieces right here, and I'm going to double distribute. So I'm going to take the x and distribute it to both pieces. So that would give me x squared plus x. And then I have to take the second part of that first binomial and distribute it as well. So I have plus x plus 1. Is there anything inside those parentheses that we can combine together? X and x. What happens when I add x and x? Not when I add. 2x. When we multiply x's, we get x squared. When we add x's, we get 2x. All right, so I've got y equals, I've got my negative 1 here. I have x squared plus 2x plus 1. The last thing I need to do here is to distribute. Will that make a difference this time? Last time it didn't.
Yes.
Yes, this time it will. So I'm going to take this -1. He gets distributed. That makes everybody negative. So I have y equals -x squared minus 2x minus 1. Awesome. Awesome, awesome, awesome. Flip forward to page 70. I want to keep practicing these ideas, but let's practice a little bit going from vertex form to standard and from factored form to standard, and then we'll look at a graph and we'll bring it all together. Page 70. I am halfway down the page. I am not at the top of the page. Do you guys see where question C is? We're halfway down the page. I'm not starting at the top. I've got my vertex form right here. When I have my vertex form, I can identify the vertex. What would the vertex be of this particular parabola? -1, +3, yes. Because this is the opposite of h, and this is our k value. When we are converting from vertex form into general form, you have to follow the order of operations, PEMDAS. Vertex form always has parentheses, but there's never anything that we can actually combine inside the parentheses. It's already fully simplified.
So we do exponents.
Yep, we do exponents first. Then we will multiply by our a value. And last, we will add or subtract whatever our k value is. So I'm going to rewrite this guy. So we said exponents first. That means my attention goes right here. I cannot distribute first because that's not an exponent. I'm going to recopy all the pieces that we're not touching right now. So I'm going to bring down the 3. I'm going to have parentheses here for the part that I'm getting ready to work with. And I'm going to bring down this other 3. What does it mean for something to be squared? Multiply it by itself. So when we say we have x plus 1 squared, what that really means is x plus 1 times another x plus 1. And that means I need to double distribute like we just did. So I take this first x and I distribute it to both pieces back here. So I would get x squared plus x. And then I take the 1 and I do the same thing with it. So I get plus x plus 1. Is there anything I can combine together? X and x. So I get x squared plus 2x plus 1. This is what goes inside these parentheses here. You guys okay with that so far? Okay, so that's the exponent step. That's the hardest step of this. After I do the exponent step, I need to distribute. What am I going to distribute to? Yep, I'm going to take this 3 and distribute only to these pieces here inside. It does not get distributed to that plus 3 at the end. So I would have 3x squared plus 6x plus 3, and then I still have this plus 3 that comes straight down. We're on the very last step. Is there anything to combine together so that I can be all the way done? Yep. That's going to give me a 6 back there. So my general form is y equals 3x squared plus 6x plus 6. This is the form that I can look at and know exactly where my y-intercept is. This right here tells me my y-intercept. For a y-intercept, you start at the origin and then you just go straight up or straight down. We don't go left or right at all. So y-intercepts always start with a 0, and then it has my spot on the y-axis. So this y-intercept would be 0, 6. Let's practice that process again with part D here. Where's the vertex on part D? 2, negative 8, yes. Here's my k value, and this is the opposite of h. We're going to put this into general form, so what do I pay attention to first?
Your parentheses.
Yep, parentheses with the exponents on it. So I'm going to recopy my original equation, but I'm going to leave parentheses here. So I have x minus 2 squared, but for something to be squared means what about it? Multiply it by itself. So now I'm going to double distribute. X gets distributed to both pieces. X times x gives me what? X squared. X times negative 2 is negative 2x. And then we take the negative 2 and we distribute that as well. So I have another negative 2x, but then I have negative 2 times negative 2, positive 4. I'm going to combine these two negative 2x's together. What'll that give me when I combine those? Close.
0?
Nope.
Negative 4?
Negative 4x. This right here is what I put inside the parentheses. So x squared minus 4x plus 4. That's the hardest step. What do I do from here now? We're going to distribute. We're going to multiply our a value. So I'm distributing the negative 1 to everybody. So I get negative x squared plus 4x minus 4, but then I still have that minus 8 on the end that needs to come down. Last thing we do is combine these two together. Negative 4 and negative 8, what do I get when I combine those? Negative 12, yes. I've got my general form. Y equals negative x squared plus 4x minus 12. Where would the y-intercept be?
Negative 12.
Give me the whole ordered pair.
Negative 12. 0. Oh, no, 0.
There you go, 0, comma, negative 12. Because remember, a y-intercept, you start at the origin and you don't move left or right, so that's why it starts with a 0, and you only go up or down. So that's why it's the second piece. All right, flip to page 71. There's one problem from factored form that I want to look at, and then we're going to look at the graph down at the bottom and bring everything together that we've been working on. I want to do part B. Any of the problems that we've skipped, I'll make sure are up in the notes on Canvas, but we're going to do part B together right here. I think factored form is easier to convert because there's no exponents, so I don't have to worry about that. When I go to do my factored form, I look at just my factors first, and I'm going to double distribute with just my factors, so I leave A out. So I take the 3x, I distribute it to both pieces. So that would give me 3x squared minus 12x. And then I take the 1 and I distribute it to both pieces. So plus x minus 4. Is there anything that we want to combine together?
3x, no, that's not square. 12x and x.
Yep, negative 12x plus x. What do I get when I combine those? Negative 11x, yes. So I have y equals 2, and then inside here I have 3x squared minus 11x minus 4. And I'm almost done. Yep, we're going to distribute, and then we're finished. So my general form, I would have y equals 6x squared minus 22x minus 8.
Can you always do it this way?
Mm-hmm. Distribute your factors first. Combine your like terms. Distribute your a value. If it's in vertex form, you do the exponents first. Then you distribute your a. Then you're going to add or subtract your k value. Where's our y-intercept here?
Negative 8. 0, negative 8.
There we go. 0, negative 8.
It'll always be 0 and negative.
It'll always start with a 0, but then the number that comes second would be how high or how low you are on the y-intercept or on the y-axis. Good question. Okay. Let's bring all these ideas together with that graph at the bottom. There's some things I like about this graph, and there's some things I don't. I like that the grid lines actually showed up on this, at least a little bit better. I don't like that on my y-axis they're not counting by ones.
They're not?
Nope. On the y-axis they're counting by 5s. So I'm not a big fan of that. Let's start off with our factored form, though. I need my roots for the factored form.
Negative 3, comma 0, and 5, 0.
Yes, here's one root. Negative 3, 0. And here's the other root at positive 5, 0.
Vertex is 1 and negative 15.
Close. This is why I'm not real pleased with how they counted on the y-axis. The vertex is actually at 1, negative 16. It's just below that negative 15. It didn't print very clearly, and so I apologize. I promise on the homework, on quizzes and tests and stuff, you'll be able to count. I'm not expecting you to have to guess where it is. All right, so I can go ahead and write that on the line as well. 1, negative 16. They tell me up at the top to assume there is no vertical stretch or compression. What would that mean about my a value?
It's not negative, and it's not more than 1.
Yes, it's not negative, and it's not more than 1. This one's not negative because why?
Because it's going up.
Yep, it's pointing up.
I was going to ask you, where did you get 5, 6 from?
Oh, for the root,
Yeah.
it's a 0.
Oh.
I just don't think it's very clear. Whoops.
No, I'm talking about when you put it on the roots right there. It says 5,
Oh,
6.
thank you. It should be a 5, 0. Thank you. I think I misread my own handwriting there. Okay, so assuming there's no vertical stretch or compression means that my A is either a positive 1 or a negative 1. And we said in this case it's going to be a positive 1 because it opens up.
Meaning none of our numbers will be common or negatives.
Yep. So for my factored form, remember factored form, we have y equals a, x minus r1, x minus r2. What did we say our a value was? 1. I'm going to need 2 sets of parentheses, one for each factor.
So positive 3 and 5.
Yep, so we have x plus 3. What's the other one going to be?
X minus 5.
X minus 5. Because it is the opposite of root 1 and the opposite of root 2. Help me out with the vertex form. This is my AHK form. What's our A value? 1. What is our H? 1. So what will I see inside the parentheses?
Plus, oh, -1.
Negative 1, because it's the opposite of H. And then what will go on the end? Negative 16, so minus 16. Beautiful. Which form do you guys want to use to find our general form?
Factor.
I think factored form is easiest, so let's go ahead and do that one. So if I'm going to use my factored form, y equals 1 times x plus 3 times x minus 5. What kind of distribution do I need to use here? Double distribution, because we have 2 terms here. So I have x squared minus 5x, and then I distribute my 3, so I have plus 3x minus 15. I've got these 2 like terms that I can combine together. So I have y equals 1 times x squared minus 2x minus 15. I feel like I need to move this down because it's kind of hard to see. Will anything change when I distribute the 1?
No.
Nope. So I have my general form now. Y equals x squared minus 2x minus 15. Where's our y-intercept at? 0, negative 15. Where's the axis of symmetry?
1/16.
Nope, x equals 1. What's my domain? Negative infinity to positive infinity. What about my range? What's the lowest this graph ever goes? Negative 16. Does it have a highest point? How do I explain that? Infinity. Nice work. Homework number 4 is due on Tuesday. You guys have the long weekend to do that. I'll make sure that any of the problems that we skipped in the notes go up onto Canvas. You access that through modules. Scroll until you see today's date. Have a fantastic long weekend, everybody. I'll see you on Tuesday.